thank you everyone for coming, and we just want to take it away right now because it's 2 o'clock. And we have 3 papers for this session. The first one will be taken by Jeffrey Pagel, which is more than just carbon, the socioeconomic impact of large-scale tree planting. And the second one, you would like to go?
Yeah, it's
okay. So the second one is deforestation, downwind rainfalls, and economic loss in Western Africa, which will be taken by Mathilde Degois.
Degois, yes.
Yeah. And the last one will be taken by me, which has to do with oil spillage and food security effects. I hope you enjoyed the session. Thank you.
Thanks.
Okay, so thank you very much for coming. This is joint work with Lorenzo Selecki, who's also at the LSE in Grantham. Okay. So what we're going to think about in this paper is whether tree planting can be used as a form of poverty alleviation. And where this is kind of the higher level is coming from the UN Sustainable Development Goals that are emphasizing ecosystem services and biodiversity conservation are essential for human well-being, and they're defining this agenda where development targets for people and planet can sit alongside each other. In the last 10, 15 years, there's a global enthusiasm that is around tree planting as a means of climate change mitigation and adaptation, but there's several questions that still remain as to kind of what is the optimal strategy, the design of these programs, and how, like, what are some of the ancillary or ecological benefits that can be derived from them. So large-scale tree planting could jointly address poverty and environmental concerns. So, and the most obvious, just through climate mitigation, that's just sequestering carbon from the atmosphere. There's evidence of climate adaptation, so it could reduce landslides. There's some evidence in both ways of whether it could reduce floods. It's less uncertain. But what we're going to be concerned about in this paper is whether it can be used to reduce poverty. And that will be through creating jobs, transferring assets into communities. Okay, so this study is based in the Philippines, and we're going to look at this program called the National Greening Program. So from 2011 to 2018, the program planted over 2 million hectares of land. This is over 1.7 billion trees and directly employed over 700,000 people. Just the expansion of the forest cover was 11.4% over the 13.2 million hectares that they had in 2010, so like at the baseline. The primary aim of this program is reforestation, but there were other further scopes for poverty reduction, food security, and ecosystem services. So the DNR, the Department of Environment and Natural Resources, forms partnerships with local organizations. These are called people organizations. You can think of these as kind of cooperatives in the community. And I'll explain a little bit further on what they are in a bit. So they form these partnerships with these POs. They pay them to produce seedlings, prepare sites, and then maintain these projects for 3 years. So there's a 3-year payment plan. The plantation assets after these 3 years are then transferred to the PO, and they can manage them however they want, and they receive all the rents or the profits that come from this plantation after that 3 years. So the research questions we're going to ask in this is, did it reduce poverty? So was the impact derived from the assets, or was it derived from the payment, and kind of disentangling the different contributions that each of these is making? We're going to also look at the village level, and we'll be able to see spillover effects into surrounding villages. So once we see that there is an effect on poverty, we want to kind of know how the structure of the economy within these municipalities was changing. So we'll kind of do some reduced forms, sectoral labor reallocation. Was it shifting, like changing migration patterns, or was it moving individuals from different sectors of the economy? And then lastly, what we'll do is we'll kind of add up what are the carbon sequestration benefits from this program. So how much CO2 was sequestered? What was the price per carbon being sequestered? Okay, so The strategy that we'll employ in this paper is a phased-in design of the program as it was rolled out from 2011 to 2018 across municipalities, and we'll also look at across villages. So some of the main findings, we find a 4% increase in forest cover. So this just kind of reassures us that the policy actually worked in its main aim of creating more forest cover. We see that there's a 6 percentage point reduction in poverty. So these are small area poverty estimates. And then we also come up with a panel data set of unlit settlements, so the absence of nighttime light, and we see reductions of 8 percentage points. Then when we disentangle the asset and the transfer, we see that they're both significant. And it seems as though that, well, they play complementary roles, but it seems as though that the asset is playing has a higher impact. In terms of sectoral allocation, we see that there's a reduction in agricultural employment, and there's movements of people into unskilled labor and services, and that there's no shifting of individuals between villages or between municipalities. And lastly, we add up kind of the benefits of carbon sequestration, and we come up with a value of $2 to $10 per ton of CO2, which relative to other technologies. Okay, so some of the contributions that we're making in here. So there's an inherent trade-off between environmental quality and poverty alleviation, and typically policies that are trying to accomplish both of these, they rarely occur. They have opposing opposing incentives. Okay. The other literature we're going to try to look at is multifaceted interventions that are granting productive assets as well as cash transfers. And this recent paper by Balboni and others looks at large transfers which create better jobs for the poor are effective means of getting people out of poverty traps. And lastly, an area that we think that there could be much more work in is kind of on the structural transformation of conservation programs. And here we're trying to think of this as a conservation program and how it can be used to shift individuals out of different sectors of the economy. Okay, so the context of this program. So historically, the Philippines has seen large reductions in forest cover. Just over the past 2 decades, they've lost 1.42 million hectares of tree cover, which is equivalent to 7.6% decrease. Okay, so in 2011, this was an executive order launched by the Aquino administration to plant billions of trees across the Philippines. So it had an initial budget of around $710 million to plant 1.7 billion seedlings across 2 million hectares. And the main places that these happen on are degraded forest lands. There's also mangrove plantations that are happening. They can also happen in protected areas, and as well as kind of mosaic cropland, so intermixed of bare land with some tree cover. Okay, so the DNR oversees nursery establishment, site identification. They provide technical support as well as monitoring to communities. And they also provide these extension services to communities, so they are planting the right trees in kind of the right climates, and they're not, planting exotic species that just grow really fast. So the DNR is going to form partnerships with these organizations. They're going to receive payment for their role in producing seeds, preparing the site, planting the seedlings, and then maintaining these for 3 years. And all profits are going to then derive back to the PO. Okay, so in terms of like fruit trees, cacao or coffee production, all this stuff will come back to the PO. And survival rate just was found to be at 83%. So this is quite a high survival rate for tree plantations. All right, the data that we'll use. So just some quick facts. So they planted over 2 million hectares, 1.7 billion trees. We have information on when the municipality and the village received each plantation, and we know how many hectares were planted, the type of commodity that they planted, and the species that they planted. So here, just on the left side, is a distribution of the plantation size that was planted. So these are over 84,000 projects. And the average hectare, or the average plantation was 16 hectares, okay? And you can see that it's the left-hand side of the tail is quite skewed. On the right-hand side, we basically classify the type of projects that these plantations were into either agroforestry, reforestation, urban, or mixed agro-reforestation. And you can see that the majority of them are agroforestry, followed by reforestation. So you can just think of as like timber production or firewood production. Okay, so here's the spatial variation and kind of the phased-in timing design that we're going to exploit in this paper. So we have, this is at the municipality level. So the never treated are municipalities that will never receive this program. So we have about 20% of the sample that are the control. In 2011, 50% of the sample will receive this program, at least one tree planting within inside of its boundary, and then it'll phase in after this. Okay. Then what we want to do is we also want to work at the village level. So we have more spatial variation or temporal variation of when these villages are going to be treated. So here we have around 78% that of villages that will never receive this program, and then 6% receive it within 2011 and 2012. And so we'll again follow when municipalities or villages receive this program. Okay. All right, so we're going to use a staggered rollout and follow this estimator by Callaway and Santana. Two outcomes that our main interest is small area poverty estimates, as well as the share of unlit settlements for a municipality in time T. The share of unlit settlements, so we build a panel data set of combining nighttime lights with global human settlement data. Okay, so you can think of this as just kind of the absence of nighttime light. And then we'll also create some event study type plots that aggregate the coefficients across time. All right, so at the village level, we're trying to replicate this dynamic effect at the municipality level to kind of reassure us of the effects that we're finding, but we're also interested in spatial spillovers, okay? So here what we're going to do is we're going to use this paper by Ferraro and Samarkir in Indonesia, and they're looking at this cash transfer program, and they're using when your neighbor is treated by this program. So kind of control villages being touched by a treated neighbor. Okay, so we're going to adopt the same strategy here. And so here is a fake island that's been created. And you can see in green, it's like when treated units. Okay, so when did you receive this program and what time? And then the blue is just going to be the control units, so control villages across the Philippines. And you're going to be considered treated when your neighbor receives that treatment. Okay? So here we have over 32,000 villages that are just never treated in the sample. And we're going to, again, use the same strategy of phasing in when they were treated. Okay. So here's the main result of this paper. So I'm going to show you a couple plots that are all based off of the same design. Okay. So on the left-hand side, we have small area poverty estimates. And we can see prior to the implementation of this program that there's no difference between the treated municipalities and the control municipalities. And we see after this that there's a reduction in poverty almost immediately, followed by a plateau, and then there's continued reductions 7 years beyond. If we go to the percentage of unlit settlements, again, we see an 8 percentage point reduction in unlit settlements. Again, we have little evidence of pre-trends, and then there's a reduction, but there's maybe a 1 or 2 year delay in when the effects are felt by the municipality. Okay, so this is at the village level. Again, we have very similar dynamics. So the direct effect is just when the village received treatment by this. And on the right-hand side, we have the spillover effects. Okay, so when your neighbor was treated by this, there appears to be economic spillovers. into the control neighbors of around 2 percentage points. Okay, so we again do like a ton of robustness checks that are, on the face value not so interesting. Some other like threats to identification that we go through, we look at 10-year agreements. So some of the POs have 10-year agreements for land. So we do some tests to see whether there's a selection bias there. It doesn't change our results. We also look at this typhoon that hit in 2013. We look at it in two different ways. So one is whether this affected ecosystems and could potentially affect our results. So if we remove the affected municipalities, we see no effect. And if we include them, there's some mitigating effect, so it could be used as some kind of climate adaptation policy. Okay. So again, we do tests on insurgency violence in the South, and we also do some tests on this conditional cash transfer program that was phased in before the policy, the NGP, and none of these other policies or violence affect our results. Okay, so what is it, the payment or the tree planting asset? So previous literature is focused on these multifaceted interventions that are granting these productive assets alongside cash transfers. And an important next step is kind of understanding where the effect is really coming from. What's important within these bundles. And so we're going to try to disentangle this effect by using kind of the natural assets, right? So the payments last for 3 years, but in those 3 years, it's unlikely that a PO can take advantage of the rents coming from these plantations, right? So it takes time for trees to grow and become productive. Okay, so we have two dummy variables. One is the payment that turns on for these 3 years when they're getting paid, and then it turns off, and then the forestry asset turns on after that year 3. Okay, so this will kind of disentangle these two effects. Okay, so here we have, again, small area poverty estimates from 1 to 3, and then percentage of unlit settlements from 4 to 6. And then we basically phase them in at different times. But in 3 and 4, we basically run regressions with both of these at the same time. And we can see that the payment and the forestry asset are both significant. They play complementary roles in reducing poverty and unlit settlements, and the magnitude for the forestry asset is larger. Okay. So we've shown that there's reductions in poverty that are coming from the assets as well as the payments. But what we want to look at a little bit further is kind of what are the broader changes that are happening? What are the changes that are happening within the household as well as kind of employment changes? Okay. So there's 2 studies that have evidence on cash transfers or work programs. So this paper in India looks at NREGs. And it finds that most of this cash payments were allocated towards consumptions or asset acquisition. There's also this cash transfer in Kenya, I believe, that shows that there's increase in consumption expenditure, but these are mostly on durable asset ownership. Okay. So again, we're just going to look at the effect of this NGP on household outcomes. So we're employing this two-period, two-way fixed effects model. And what we find is that there's increases in electricity in NGP municipalities. There's increases in television expenditures. And there's also increases in individuals buying refrigerators. All right. On sectoral employment, we want to look at how individuals are shifting. So here what we show, so it's the same model as what I just showed on the assets. But what we see is that there's more people working in services, around 2.5%, more people working in unskilled labor, and reductions in people working in agriculture. Okay. Labor reallocation, I'm going to keep this short, so we don't see any effect on individuals shifting across municipal borders or village borders. Okay. Lastly, what I'm going to do is I'm just going to go through, we try to calculate how much, like the value of sequestering carbon. Okay, so what we're going to use is this study by Belenge who's calculating the annual carbon sequestration rate per hectare within a 99-hectare plantation in the Philippines. He comes up with these two carbon sequestration values, one for dominant species and one for codominant species. We can then apply this to all 84,000 plantations within the data set, and we see that the NGP sequestered 73 million tons of CO2 to 308 million tons. Okay, so this would be equivalent to 17, that should be 17 million gas-powered vehicles driven in a year, or 20 coal-fired plants. If we take this as a fraction of the entire total cost of the policy, we see that it cut emissions by 2 to 10 degrees, or $2 to $10 per ton of CO2. Lastly, what we do is we apply a monetary value. So we use the social cost of carbon for this, and then we use a 3% discount rate and a 5% discount rate. And what we see is that the plantations become profitable by years 6 and 9. Okay. Am I out of time? Okay, great. Thank you very much.
I guess maybe you can conclude as we are only 3 in the session.
Okay.
Okay. Okay, so to conclude, so there's valid concerns around tree planting. Okay, so I don't know if there's any ecologists in here, but so the scale of land that's required, the timing and permanence of CO2 reductions, and there's potential ecological impacts that can come from tree planting. Some other work that we're working on is like whether this is changing cropland and production, so food production. There's also a lot of questions about permanence, so whether these tree plantings will last indefinitely. Okay. There's a couple elements though that about the NGP that like the design elements that were crucial to its success. Okay, so one is just engagement with POs. Second was long-term incentives to local organizations. So there's these payments that are coming in over several years. There's managerial control that is going to plantations, as well as kind of transferring the asset to communities and allowing them to choose how they want to manage that resource. Okay. So just in conclusion, we show that this NGP, this tree planting policy can be used to reduce poverty as well as provide an environmental benefit. Okay, thank you.
Okay, sorry. Okay, thank you very much for your presentation. I really enjoyed reading your paper, and actually it was already pretty well advanced, so I had a tough time to find comments. So a bit of an overview of the paper. So you evaluate the Philippines National Breeding Program, which is really impressive program, well designed, as you stated, on the diversity and the work with the local partners. Classic staggered diff and diff, Kalawa and Santana, information on forest cover, poverty, and labor reallocation, with an effort in disentangling the assets versus the cash transfers. So I really like this idea of more than just carbon in the way you talked about it in the paper, and I think it's a really important and policy relevant question, especially with regard to the jobs and with regard to the fact that you find long-term effects that last in time. And also you have novel data on unlit settlements, which allows you to have a proxy for property in a panel way. So it's also an important contribution, and that I liked from your paper. So very briefly, I was wondering if you had any insights or information about potential treatment leakage and the fact that areas next to the reforestation program could have actually deforestation, which could increase your results upwards. So I had just a question about that. I was also wondering if the observed reduction in the build-up area was actually due to tree planting obscuring the settlements and actually trees growing above those unlit settlements, and so they are not actually disappearing, they are just not seen like detectable anymore, even if I was still convinced about your empirical strategy because you have this in situ poverty information as well. So I was also wondering, could these settlements have been intentionally targeted for reforestation, for example, especially in peripheral and forest adjacent zones? And in the same way, how did they target the municipalities to be treated in priority? Because in your paper, you state that likely, like you use the staggered setup, because it's likely that the government prioritized areas with greater potential for conservation and greater scope for poverty reduction, but for me it could still be the case in the staggered setup. So maybe they chose the 2011 villages and areas because of that. Also about the question about the irreversibility treatment, I'm convinced about it with regards to the forest cover, but with regards to the employment effect of the policy, which is central in the analysis, I was a bit more skeptical. So, for example, jobs that are likely short-term and transitional, like planting the trees, etc., could end, and so your assumption of the DND won't be available anymore. About the migration, I was also a bit puzzled. So you argued that you are not seeing any changes in the population and that migration is not driving the results. But so I was wondering about those transient workers. Where do they go? And also I was wondering if actually in the data, you could see if the unlit areas were becoming lit areas or forested areas in the same way I've just said just before. And where are those people going? Are they actually becoming less poor and living in lit areas, or are they just being hidden somewhere? In the same way we in Paris hid the homeless people during the Olympic Games. With regard to the migration test, so you use the Landscan data, but Landscan uses census and nighttime rights. So it's likely that they are undercounting poor and migrant population, especially in those reforested, remote and unlit areas. So maybe you do not observe changing migration or population change in the rich areas, but you are just not reporting the poor ones because it's not capturing properly the effects for the poor people. So yeah, I'm just wondering, are these people really becoming more richer, or are they just gone from on another place? And also a couple of open questions. So you quantify carbon, but not poverty in a way, like I just would like to know if you have any insight on how many people lived in those unlit areas, what is the size of the population we are talking about here. You also make a great effort in disentangling the effect of payment and assets, so I'm not going to be too specific on the topic, but the program embodies, as you said, a lot of different informations. And for further research, I was thinking, okay, could you do something about agroforestry? Because it's an important topic. I'm interested in it also, and you have data, so that could be nice if you could do it in the future. Also, who is benefiting from the actual policy? Is there any gender differences? Sometimes we know that women do not benefit the same way of interventions than men, so I will be glad to know about this. Do you see just your insight about market spillovers? What is the consequences on wage and timbers or price effects in the neighboring regions? Do you see heterogeneity across the islands? Do you see other positive spillovers? Of course, classic question, education, health, etc. And also, I think one of the big aspects of your program is the community aspect, which is really important and really nice. And that could really explain why this program is such a success. So maybe you have like room for research in that direction too. And minor comments is just I was wondering why not using Hansen or the tropical moist forest dataset for the forest cover. Yeah, the rest is not really relevant. Yeah, that's it. Thanks.
So thank you for these comments. I will just take a couple of them. Like displacement and leakage. We have a second paper now that's like looking at like how it's changing land use, and whether it's actually shifting deforestation to other areas. So that's should come out at some point. Some of the other ones, like, so in terms of job creation, these are like the second part of that panel is coming in 2017, so it's actually quite long term, but we can't see like where these people are working, and the department actually doesn't know. So the labor statistics that they report, they can't tell you exactly who these people were working. Okay, so yeah, I mean there's statistics in that are not very good. And like, yeah, so like these 10-year agreements, we do some work to basically detect like, you know, whether one of these is driving and it's not the tenure. So any other questions though? Yeah.
I can speak louder now.
I'm interested in the structural change part that you presented at the end, because the way you presented it, it seems a little disjointed from the rest of the paper. I appreciate that you maybe don't want to lean too much on it because the significance levels are not that strong. But I'm wondering, you know, does it inform us about the main results that you find? For example, is there a route through which this structural change effect can have led to the poverty reduction effects or otherwise? And a way you could get at that is if there's some way that you can show us which sectors are more productive or generate higher incomes in the community as opposed to others, then a structural change effect towards a higher income sector, higher productivity sector might be a mechanism through which your main result is manifesting.
Yeah, so we're trying to do something on like agroforestry because that's the one that we think is like moving individuals out of agriculture, right? So agriculture is just becoming more productive because agroforestry needs less individuals. And so we're doing some work at the village level to see whether our effects are through the agroforestry versus the other ones. Yeah, any other questions?
Yeah, I guess just on that, the first point where you touched upon, I guess thinking about Africa, it seems like in the short and medium term, agroforestry is more viable, at least for like smallholder farmers. But one of the things I've seen is it's quite hard to convince them to like see its benefits. Is there anything you could touch upon that? I'm going to miss something in the beginning about the asset transfer, like encouraging them to adopt it. But yeah, anything on getting farmers to adopt agroforestry?
The thing is what's quite unique about the Philippines is there's these people organizations that are basically undertaking these projects on behalf of the community. And so I don't know if this exists in parts of Africa, but this is like central to how this program was successful. And so it's not individuals that are kind of risking their own plots. It's the people organization that's pooling resources together. Yeah. Okay. Yeah.
I have a question on how can you disentangle between the long-term effect of payments and free assets? Because if I understand well, it's only based on timing. So maybe it's like more a multiplier effect or an investment of fast payments to second.
I see. Wait, can you repeat the last part?
Like maybe it's just the investment of this payment that then is transformed into like less poverty and not the effect of forest assets.
Yeah, so we argue it in two ways. So one is the event study. You see an immediate drop in poverty, and then it plateaus, and then it goes to another reduction, right? So if it was as expected as you said, right, where they use that payment to then invest in some productive asset, you would expect it just to continuously decrease, right? You wouldn't expect this plateau, okay? And then the other one is through these two dummies, right, that are turning on at different moments. Okay, thank you.
Okay, so hello everyone. Today I'm going to present you this paper entitled Deforestation, Downwind Rainfalls and Economic Loss in Western Africa. This is joint work with both my PhD supervisors, Thomas Vendries and Julien Wolfer-Berger. So a bit about the motivations for this paper. First of all, deforestation is a major concern globally. It's responsible for greenhouse gas emissions, as you may know, and biodiversity loss. And it also affects rainfall patterns, which will be the focus of this paper. Changes in rainfall affects all development outcomes, and there is large spatial effect across borders. And especially in our context in West Africa, deforestation has emerged as are really increasing. In our sample, we have 30% of the total forested area that has disappeared since the 2000s. And as we may know, in Africa and West Africa, most of the food production relies on rain-fed agriculture with really low adaptation strategies such as irrigation, for instance. So in this paper, we examine how deforestation influences downwind rainfall and its consequences on key economic development outcomes in West Africa. So the paper is divided in two parts. The first part will be to assess the impact of deforestation on precipitation. So we show that a 1% increase in deforestation decreases precipitation by 1.4 micrometers, which is broadly 5% of the precipitation compared to the mean. And the effects are spread up to 200 kilometers away from the pixel of the deforestation, the deforested pixel, sorry. And in the second part of our analysis, we are going to work on the consequences on the development outcomes. So this is still work in progress. So any feedbacks will be more than welcome. We show that there is an heterogeneous effect on GDP between rural and urban areas. We show that there is an increase in out-migration also in rural areas. And more broadly, an increase in low-intensity violence events, such as the number of demonstrations and protests. With regard to the methodology, as we face indigeneity issues, we will combine first satellite data on deforestation, climate, and economic outcomes at the pixel level. So we'll work at different level of resolution. And we will exploit the exogenous wind directions to identify causality. So we will connect distance pixels together on the grid through that backward wind path. So we contribute to several strands of the literature, the first one being linking forest conservation and rainfall to economic outcomes. So the closest papers that are talking about this subject in the literature are the one of Adejumo, who studied the effect of deforestation on rainfall in the context of the Amazon. And Grosse and co-authors recently also worked on a reforestation project, this time in the US. They both those papers show that there is a decrease in rainfall and consequences on agricultural productivity. Here, we are going to work in the context of West Africa. So as I said, it's an economy heavily dependent on rain-fed agriculture. And we are going to go a bit deeper into the development outcomes, looking at migration, GDP, and conflicts, rather than just rainfall and agricultural productivity. We are also talking about the large and growing literature on the economic drivers of deforestation, but this time we focus on the reverse impact, so the impact of forest loss on economic activities. And we document significant externalities of deforestation on development. And we are talking to the forest clearing and precipitation in natural science literature that started to talk about this topic actually in the 2012 with the Sparken et al. First paper, so we are a bit late, economists. And here we are quantifying economic impacts. Okay, so a bit about the background. So in West Africa, which will be our region of interest, including as well Burkina Faso, Niger, and Mali, etc., for the economic outcome analysis. We have 28.5 million hectares of forest that have disappeared since the 2000, which represent 30% of the initial forest cover in our sample. The primary driver is for Côte d'Ivoire and Ghana, for example, cocoa expansion, but more broadly agricultural expansion. And for example, it led to the clearance of 90% of the forest cover in Côte d'Ivoire. So this is the initial forest cover in our sample, and this is the current forest for in 2002. So the red dots are all the deforested pixels. The region also faces various critical development challenges. 95% of African food is rain-fed, leading to low adaptability to rainfall shocks. There is also a huge political and social instability. So this is the level of resolution we are going to work at with regard to the development outcomes. So we just summed up the number of ACLED events per grid cell for the entire period of interest in the region of interest. And there is, of course, food security and health, which remains major concerns. A bit about the mechanism we are going to work in this paper. The mechanism is really simple. Forest creates evapotranspiration, which creates clouds and then creates rainfall downwind. If you cut down the trees, there is no evapotranspiration anymore, or at least less evapotranspiration, so there is less cloud formation, less rainfall, and therefore consequences on the agricultural development and more broadly on the other aspects of the development. So deforestation creates, an increase in deforestation creates a decrease in rainfall and consequences. So the first part of this paper, as I said, will focus on the impact of deforestation on rainfall, and then we will look at the development outcomes. In terms of the identification strategy, of course, we face two main problems: reverse causality, so economic activity impacts deforestation. This is what the vast majority of the literature is looking at. And we also have endogeneity issues, so confounding factors can impact both deforestation and the development outcomes. So here we will exploit exogenous wind direction by constructing those backward wind paths. We look at distant spatial scale to deal with local endogeneity, and we control for time varying and geographic characteristics. So with regard to the data, very quickly, we have climate data from ERA5 and ERA5 land, so total precipitation, wind direction, atmospheric pressure. We use Ansonet co-authors forest cover datasets. We take the EHS of the total area deforested in square meters. We combine this with Chen et al. GDP, gridded GDP data, migration from Niva et al., and conflicts from ACLED. So, a bit about the identification strategy. We have our origin pixel G, which which cross a backward wind path, which allows us to connect the destination pixel P to this origin pixel G. And the first part of analysis for this identification strategy on deforestation and rainfall, we are going to select all of the pixels that are crossing this backward wind path for this destination pixel E. So, more specifically, we will use the resolution of 0.1 degrees times 0.1 degree, which is like broadly 11 by 11 kilometers at the equator. Y is the precipitation in millimeters at destination pixel E at year T in months M and in country C, because we have also the level of resolution monthly. We have the deforestation of origin pixel G at year T in months M and country C prime. So maybe the backward can cross the borders, okay? We have pixel and months times year times district fixed effect, which is the most restrictive specification we could implement. And we cluster the standard error at the pixel level. So this is the first result of our analysis. You have the distance from the pixel in kilometers in the x-axis and the precipitation in the y-axis. And what we see is that there is a decrease of precipitation close to the deforested pixel, and then it fades away approximately around 200 to 250 kilometers away from the deforested pixel. In the second part of the analysis, we are going to deal with the endogeneity issues close by to our pixel and our deforested pixel. So we are using the same setup as before, but this time we are going to create a buffer of 50 kilometers around the deforested pixel in order to account for endogeneity, and we are also going to exclude all the pixels that are farther away than 250 kilometers. We have several bandwidth robustness check, which are all robust. And we are going to sum all the pixels in this 50 to 250 kilometers away from the destination pixel as what we are going to call upwind deforestation, so the total deforestation exposure of our downwind pixel. With regard to the results, so we have the total deforestation from 50 to 250 km destination pixel E called upwind deforestation, and we observe a decrease in precipitation of approximately, as I said, for the specification with all the fixed effects, 1.4 micrometers of precipitation, which is broadly 5% compared to the mean of precipitation. This accesses the mechanism and constructs the independent variable that we are going to use in part 2. So this upwind deforestation is robust to different bandwidth and different atmospheric pressure. I can enter a bit more into the details, but it's important for the exogeneity assumption actually. So we are able to construct this exposure of deforestation. So this is our full region of interest. As you can see, the forest is not identified, for example, in our previous slides in Burkina Faso, but we have an exposure of upwind deforestation in up to those areas. For the specification for the second part, we will look at a more broader resolution, so 0.5 times 0.5 degrees, it's broadly 55 kilometers at the equator. And we are going to take into account this time lag variables, because the impact of deforestation at day t could impact actually the development outcomes at day t plus 1, t plus 2, etc., etc. So we look at 5 periods onwards, and we have again pixel and year country times fixed effect. We cluster the standard error using Conley clustering to account for spatial autocorrelation, and we add also HAC clustering, so time and spatial autocorrelation of the standard error. And here our outcomes of interest will be migration, the log of GDP, and the number of Ackland events, demonstration, etc. So a bit about the results. We have, so in the y-axis you have the period of upwind deforestation exposure, and here we are looking at the log of the GDP. So we disentangle the pixel categorized as rural and as urban, and we observe that there is a decrease in rural GDP following an increase in deforestation, up to 3 periods from the first date of deforestation, and an increase in the urban areas, and those effects fades away 3 periods onwards, so 3 years after the first deforestation occurred. In the same way, for rural net migration, we have a negative impact on net migration, meaning that people are leaving the area. So in terms of magnitude, it represents 0.2 people per 1,000 person, which is approximately a decrease of 1.2% of the population in our full sample compared to the mean. And with regard to demonstration, so this is also robust to different categorization of what is low intensity violence, but we observe that there is an increase in the number of demonstrations from the first year of deforestation up to 5 years onwards, which is quite logical if you think about the mechanism, because people in a difficult situation say because of the decrease in rainfall can go to the cities and protest in order to do that, and we do not find any evidence on high intensity violence, even if there is a slight increase at the end of the period. So we believe that an increase in deforestation in the first period do not impact, let's say, armed conflicts or jihadist events or fatalities, which are all very correlated in the region, but that maybe at some point there will be effects at the end of the periods, but we do not know for sure about that. So we have a bunch of robustness check, different bandwidth, different atmospheric pressure controls, dropping the border pixel, dropping Côte d'Ivoire and Ghana, because as they are almost price makers sometimes on the cocoa market in their duopoly position, an impact of deforestation in Côte d'Ivoire, let's say, could have an impact of the choice of development actually in Ghana. So our hypothesis of long distance effect could not hold in that case, but it's still robust. We are dropping extreme values, we are weighting the variable by distance, we are using other specifications than the EHS and other units of our deforestation variable. We have also alternative definition of conflicts, it works as well in the intensive and in the extensive margins. So the incidence of conflicts, do we see a conflict as there were no conflicts before, or do we see an additional an additional event of conflicts in areas already subject to conflicts? And we still need to do a robustness check about different thresholds with regard to Hansen and co-authors, and using the tropical moist forest database. So to conclude, we exploit exogenous wind path to show that an increase of deforestation decreases the precipitation up to 200 kilometers away, so approximately 5% decrease in precipitation. We show that there is a decrease in GDP and an increase in out-migration in rural pixels, and an increase also in the number of demonstrations. In terms of policy implications, we think it's a really important question. It links sustainable forest management with development and more broadly cross-border effects, which leads to the question about global governance. And currently, we are thinking about looking at the effect of nutrition and health using notably the DHS data. And also, I'm investigating a nonlinear effect because from the climate, let's say, literature and the first regression I'm starting to run right now from the past week, it seems that the effect might be an inverted U shape, meaning that the very first level of deforestation and tiny values could increase actually the level of rainfall, and then there will be a threshold and a decrease afterwards. Thank you.
Yes, thank you very much for the presentation, and I must say that it's quite insightful, and well done to your supervisors. Due to the structure of the timetable, we weren't sure of your comment, so I just have some general comments on the paper, and more technical comments are welcome with regards to the identification and the use of technicalities to other technicalities to look at the things that were used for identification. Now, the study actually looked at the effect of idiosyncratic variables in rainfalls in one area and how it drives deforestation or the reverse causality, as it were. And then the findings that we saw was that it was able to validate the role of negative externality of deforestation from one place on distant locations. Now, the variables or the development outcomes that you look at include GDP. I'm not sure, but I think I read something like agricultural productivity.
Yeah.
But it wasn't mentioned here. Then the issue of the issue of migration, and then conflicts, as it were. Now, I have, like I said, general comments. I'll think of development outcomes as, yes, GDP, and issues of things like livelihoods, and some more pertinent development issues. And most of these outcomes that you actually chose appear to me more like mechanisms. For instance, the issue of, like I said, agricultural productivity, it's a component of the GDP. And those are some of the things that actually tell us what GDP, what we use in calculating GDP. So I'm thinking of it as a development outcome variable. Gives me some things to think about. Then the issue of conflict and net out migration. I was also wondering if they could also stand alone as development outcomes. Well, that's just a poser for you to actually think about. Then I have a little issue, although you're able to use the pixels and co to validate your identification strategy. But I know that in quite a number of studies have actually used the wind direction as as an identification strategy. But it just got me thinking that the direction of wind is actually used for energy production. And they actually also apply to components of GDP because the production of energy also culminates into what we factor in to calculate the GDP. So I don't know how you want to justify that as a standalone or as an exogenous variable to explain some of these development outcomes that you actually chose. Then I was just wondering if there are mechanisms by which we could look at the net out migration that is negative. There are ways we could look at remittances, if they can actually offset these effects that we see in the deforested areas that you actually spoke about. Those are my general comments. I don't know if we have comments from the House, but I'll allow you to respond first. Then take it from there.
Okay, thank you for your comments. So very quickly, with regard to agricultural productivity, it's true that in the version of the paper I sent earlier, there were some tests of do we see impacts on NDVI and EVI, but actually we do not believe that NDVI and EVI are good proxies for agricultural productivity, especially in our context, because it can also be confirmed with the forest cover, so that's why I haven't presented it in the paper. But we are actually thinking of showing this effect on agricultural productivity. Do our economic outcomes stand alone for economic development? I would argue that yes. Of course, they are all correlated, but I think it's still really important relevant policy issues. And yeah, maybe I can take questions from the people here if anybody has insights.
Congratulations, Mathilde.
Thanks.
If I'm not mistaken, in the first part, you just like cluster your standard error at the pixel level.
Yeah.
So I was wondering why. And there is also a literature that showed that a decrease in rainfall causes deforestation. And so I don't know, how could it work? But could you have a story with your wind path and stuff like that? In one area, you have the deforestation that decrease the rainfall, and further down, you have more deforestation because of the decrease in rainfall or something like that. But yeah, congrats again.
Okay, thank you very much, Sebastian, for your comments. So with regard to the clustering of the pixels at the pixel level in the first specification, we also do it using 50 kilometers this time, Conley clustering. I just haven't shown the result here because it takes a lot of time to run the regression using the package, because we are also considering the time autocorrelation. So we are taking the monthly time correlation and the spatial correlation, but we are also clustering actually with regard to that. And for the impact of rainfall on deforestation, this is a really nice comment. Actually, Adejumo shows in his paper that there is a cascading effect. So that could be something we'll need to look at. I don't know yet if it's increasing the effect we are showing, or if it's not really in terms of magnitude important, but actually believe that there is this cascading effect at the place, and this is important to look at. So yeah, thank you, really noted.
I have a couple questions. So one, do you control for cloud cover?
For?
Cloud cover?
No.
Okay, and the other one I'm thinking of is, and then the second, so why don't you do all of Africa? So you have, I know it's computationally intensive, but you have all your data can be done across Africa, right? And so some countries that have a lot of deforestation could be impacting your region of study.
Yeah, thank you for your comment. So we wanted to work on all sub-Saharan Africa at least, but as we wanted to link the pixel at a very high resolution level with regard to the analysis on rainfall, thanks to all the comments from the climatologist people and remote sensing people, we cannot aggregate the precipitation data at 0.5 degree pixel. That would be not relevant. So we chose West Africa because the wind pattern in West Africa, as we can see in this graph, are actually blowing from the ocean. So we had an exposure of the people downwind in this area, whereas in the rest of Africa can be completely different with regard to the path. So we chose West Africa, but of course we would like to do it for all sub-Saharan Africa. And yeah, we are wondering if we are going to do it. But it's really computationally intensive.
Yeah.
Okay, well, thank you very much for your attention.
So thank you very much for staying through till this time. I'll be presenting on the topic food security effects from environmental degradation, evidence from crude oil spillage in Nigeria. And basically, I worked with a number of colleagues as presented. And the motivation for this study stems from the fact that crude oil leads to oil spillages, and where you record the number of spillages and environmental degradation, and this leads to inexhaustive issues, from the issues of poverty to the issues of human deprivation, inequality, ecological challenges. Most vulnerable people are affected by these crude oil spillages. These vulnerable people include the poor and the socially deprived people and low-income people that can actually mitigate the effects of these crude oil spillages or find ways to cope with crude oil spillages due to their low-income ability. Great attention has actually been placed on the issues of greenhouse gases, climate change, extraction and burning of fossils, and a form of pollution that has not been really studied is the issue of crude oil spillages. Crude oil spillages in Nigeria is about 37 billion. Crude oil reserves in Nigeria is about 37 billion barrels, and this is about the second largest in Africa, next to Libya. And the production average of crude oil in Nigeria is about 1.7 million barrels per day. Like I said earlier, the environmental impact from crude oil is looming. And one major motivation for this study is the resource development dilemma. That is, the desire to grow, the desire to involve economic activities, the desire to engage economic activities to drive economic growth, and the challenge of sustaining environment and achieving development. In terms of relying on crude oil as a source of energy in developing economies, it's a growing issue vis-a-vis the challenges of, like I said, sustaining environment. Then we have the cost of alternative energy. It's a bit high, and that makes people to still want to use crude oil or use fossils, as it were. Then they increase the pressure of national budgets, and the need to grow your income makes the use of environmental resources a continuous phenomenon. And households and economy transitioning to to issues of sustainability appears echoing because of the cost involved. Then oil spillage, pollution, and the burden is there. It affects social individuals. It affects the social health social well-being of individuals, including their physical and mental health. It affects their economic outcomes, including incomes and livelihoods, and also the ecological outcomes, which has to do with environment damages and biodiversity loss. So the overarching issue that is of interest in this study is oil spillage, the aftermath of oil drilling, and some other activities that are associated with drilling of oil. This is because of the low regulatory environment in Nigeria and the way it predisposes low-income household to the issues of the aftermath of spillages that happen from these economic activities. So what is of key interest to this study is to evaluate the effects of pollution from oil spillage and how it affects development. And the policy focus is to advocate for funds or cash transfers or push efforts that can actually assist vulnerable households to cope with environmental shocks. The overall objective of this study, like I said, is to assess the effect of crude oil spillage in household locations on local level food security in Nigeria. The research question we pose is, does oil spillage result in adverse food security consequences for households around the spillage location? And what exactly is driving these effects? And the reason why we actually chose Nigeria for this study is because Nigeria is known to be one of the leading crude oil exporters in Nigeria, globally, and it ranks number 97 out of the 113 countries in the overall global food security issues. That's the lowest. And over 50% of West Africa's population appear to be insecure with regards to food security. The methodology we used was to geographically match a georeferenced data set on the subnational distribution of crude oil spillage in Nigeria using data between 2010 and 2016 we matched it with the LSMS survey data for about 5,000 households. And then we compare food security experiences of these households residing close to spillage site as at the time of the survey to those residing in locations without any form of this crude oil spillage issues. We try to use a diff-in-diff identification strategy, and then majorly the findings lend credence to the fact that widespread food insecurity experiences of households around spillage sites for the residents were seen. The research, the contribution to knowledge stems from a general overview of the socioeconomic consequences of environmental degradation or pollution. That is, we have a number of studies that have actually done things on labor productivity, on labor supply, on human capital accumulation as a result of environmental degradation. So we're contributing to the broad knowledge on socioeconomic consequences of environmental degradation and pollution. And then also, we're contributing to the emerging literature on subnational geocoded data to generate evidence by exploring the impact of the distribution of oil spillage within a developing countries' context. We also discover that there are depth of studies on food security effect on oil spillage within the area of interest or the context that we're looking at. We have a number of survey responses, but that has made attribution very difficult for us. So very difficult. So as a result, by doing some, by exploring some other data sets, we believe that we can add more evidence to these issues of food security and crude oil spillage. The focus on food security effect by considering household experiences of food access and availability around the spillage site. That is, there are less systematic evidences in this regard, and we know that by doing this analysis, we can add to the literature on food security effects given oil spillage issues. Now, on the context of the study, crude oil was first discovered in Nigeria in the 1956 and in commercial quantity. And in 1970, at the end of the popular Biafra War, that period coincided with when there was a rise in oil prices in the global space. And that led to rapid accumulation of capital in Nigeria. And it also culminates into the time when Nigeria registered with the Organization of Petroleum Exporting Countries in 1971. Nigeria produces about 1.7 million barrels of oil per day and has a reserve of over 37 billion reserve of crude oil. The oil spillage is a function of formal and informal activities, and over 15% of informal activities such as bunkering, illegal mining, account for these spillages that we have in this context. The lower region of this map shows the area in the Niger Delta, while the other parts are the non-Niger Delta zone that do not experience extraction, drilling, or spillages. The world's second largest delta is actually in this Niger Delta, and it is the largest wetland in Africa and the third largest in the world, and it's located on the Atlantic coast of southern Nigeria. The Niger Delta consists of rivers, creeks, estuaries, and stagnant swamps covering approximately 86,000 square kilometers. The delta has mangrove swamps that spans about 1,900 square kilometers. What are the fallouts from this spillage? Industrial scale drilling in Nigeria has resulted in pollution from oil spillage. Operational mechanical failures and illicit activities have also ensued. That is, we have sabotage, we have pipeline vandalism, which has aggravated the issue of spillages. We have little spillages in coastal areas that diffuses to other areas across the Niger Delta. Then we have the effect on wetland soil that by lowering the fertility of the soil, and it also results in incidences of fire that leads to respirable particulate matters that can affect the health of human beings. And it also leads to issues of acid rains, rainfall, and the likes. Now, oil spillage and food security is not thought of as a straightforward effect like that. We think of some direct and indirect mechanisms that could explain some of this. We expect that environmental degradation, which is as a result of oil spillages, can lead to issues of reduction in farming or farm production and food production, and it can also lead to reduction in household and market supply of food consumption. then we also see that it can have indirect effects in terms of human health as a result of environmental degradation, and at the end of the day leads to issues of food security. So we used, like I said, a geographically or georeferenced oil spill monitor data from the National Oil Spill Detection and Response Agency in Nigeria. We matched it with 3 years of the Living Standard Measurement Survey from 2010 to 2016, and that's for 5,000 households. And then we used spillage with physical environment implications by restricting the analysis only to spillage locations with precise geocodes. The geocodes of survey LSMS household location of residents in enumeration areas were actually looked at, and they were mapped with the villages and neighborhoods within the areas of interest. We measure the distance from the enumeration area, from the center point of the enumeration area to the crude oil spillage location. And then we match this data with the LSMS survey. And then we use the cutoff distance of 75 kilometers. Some of the results at lesser kilometers showed consistent direction of the result, but with less significance or no significance due to the issues of power. We found out that there were less households that were close to the spillage site, and that is reasonable because a lot of people try to move away from the oil spillage location. We were able to show that the crude oil spillage across the years was somewhat reducing food security amongst the households that were largely exposed to the issue of crude oil spillage. We adopt a spatial temporal estimation strategy that has been used by this set of persons, and the issues we consider include specific timing of the oil spillage, the localities of the spillage, the year of the survey, and the local households residing in areas of an active spillage site recorded at 6 months of the time of the survey in the Niger Delta were the treatment group, and the non-Niger Delta cluster were the comparison group. The study adopts a different strategy, and we actually use the distance cutoff as the independent variable, which is used to explain the food security outcome for households or for household residents living in the locality of interest. We controlled for spatial fixed effect, and then the survey year, the state fixed effect, and the standard errors were clustered by enumeration areas, given the LSMS data that we used. The descriptive statistics show that food security, about 21% of the population had issues with were insecure with regards to the food, the variables that were used for the food security. And then the results showed that about 9 variables were actually captured by the LSMS data for food security. And those 9 variables were aggregated to explain food security, while we now use the limit portion size, less preferred food, and limit variety as the main disaggregated variables, because it will be too lengthy to use 9 of them. So the aggregated one actually showed that an increase in food security, an increase in oil spillage for those close to the site of the spillage actually caused them to be more insecure with regards to their food intake. The sensitivity analysis, like I said earlier, showed that at 50 kilometer proximity, the pattern of food insecurity was consistent, but the results were not as significant as though. And then for 75 kilometers, we had consistent estimates of reduction in the food security of the people close to the site. The mechanisms we used in explaining this result are economic and health outcomes. We used labor input and agricultural yield to explain these outcomes. For labor input, we didn't find significant estimate, although we found that for those who are close to the site of the spillage, there is a reduction in their labor input and significant estimate for the agricultural yields. That is, there are reductions in the agricultural yields. And then for the health estimates, that is, we found that the health expenditure of those who are close to this site actually increased as a result of exposure to crude oil spillage. Now, the heterogeneous effect shows we actually used remittances as a cushioning mechanism for explaining heterogeneous effects. That is, we asked the question, how can households experiencing food insecurity due to oil spillage in their locality cope with crisis, noting that this given the adverse effect on agricultural and health outcomes. And in Nigeria, we discovered, the popular phenomenon, by the reports from the ILO and World Bank, shows that there are weak institutional frameworks for social protection and social insurance programs. So, to what extent can remittance inflow actually proxy for cash transfers to mitigate the issue of oil spillages or those exposed to oil spillages? We expect that those who have some forms of additional income or additional cash will be able to mitigate the effects of these crude oil spillages. And as a result, by breaking the data into two, we had evidences of those who had some extra cash through remittances having a reduction in the effect of crude oil spillages. And that's indicative of being able to find some way to adapt in terms of their, or to be able to cope in terms of their food consumption and security. In summary, we find a consistent pattern for the food security indicators, that is, higher food insecurity for those who are closer to the consumption site, or for those who are exposed to the crude oil spillages. Then household food insecurity pattern exists because the spillage affects household agricultural production and health for productive economic engagement for food access. Then we also find that remittance receipt reportage changed the narratives for those who actually are exposed to crude oil. That is, those who have some form of extra cash transfer through remittances are able to mitigate these effects to some extent. Then we advocate for liquidity boost or institutional effort or push for vulnerable households to cope with environmental shocks. Thank you. These are just some limitations for this of the study. We refrain from doing a causal impact, or we refrain from implying causality due to the strength of although the strength of identification was quite good, but we refrain from implying causality due to the power that was actually available of the samples that were available to us. Then a field survey that compares households exposed to such shocks to unexposed household in periods before and after the spillage can help to substantiate some of these claims. Then we encourage field works beyond the country Nigeria that we have actually looked at to be able to establish or to validate the effect of environmental degradation on crude oil spillage. Then, like I said, due to power issues, we could not show evidences for more closer proximities. That's like 10 kilometers, 20 kilometers. We'll highly power such evidence if we get more data and obtain more evidence on whether crude oil spillage can also affect psychological well-being, like mental health and the likes, is also advocated. Thank you.
How do I make it big?
Control L.
Control L. Okay, nice. Okay, so thank you very much. I learned a lot about Nigeria and about oil production and oil spills from this paper. Here, I'm just going to offer some comments on ways that you might be able to improve it. Just take whatever you want and discard the rest. Okay. Okay, so my comments are broken up into like minor comments and more like substantial comments. So one, just define. It would help if you defined food security much earlier in the paper because it was quite unclear what was actually meant by that. Second, I think there's work by Jonah Rexer, who's done quite a bit of work in Nigeria on oil. So here's two papers that he has on violence in black markets as well as corruption and local advantages that the local advantage of oil production. There's a couple of robustness checks that I think you could do that would be kind of like easy to implement. So one would just be kind of changing the time of when oil spills happen. So you can move it earlier, and if you see no effect, right, then we can say that this is identified as the spill. Or even like placebo tests, like looking in areas that, kind of your control areas and kind of just like shocking them randomly with oil spills because then you shouldn't see an effect, right? Okay, so substantive comments. So I know that you have the geolocation of the spill, but like, do you have the area of the spill, like the shape file of where oil went? And also like maybe you could provide some evidence on the intensity of spillage. So you have the extensive margin of whether there was a spill or not, but it's not clear like if there's like a measure that could be used of like how much oil was spilled, right? So not all oil spills are created equal. Okay, you use this cutoff of 75 kilometers. So at the end, you just hinted at like power issues of like using closer measures, but what you could do is kind of bin the treated observations at 0 to 30, 31 to 60, and then 61 to 90, and see kind of a gradient of kind of an effect on food security, like how oil is affecting, right? We would expect the closer ones to be more affected than the further away ones. So yeah, are closer households more affected? You kind of get at this as like, if you're within the 75 kilometers, and we would expect kind of a decaying effect across these different bins. Lastly, like when you test these health effects, could you focus the sample on only residents who are listed as agriculture? And because you're trying to get at agricultural households versus non. So one would be just to look at the health effects of just agricultural households. And then the other one is like focus on specific health outcomes that are related to oil spills. So one I'm thinking of is respiratory illnesses from when oil is being burned versus like other health effects that would have, like no relationship with oil spills, right? And again, that's kind of a placebo that you'd be able to see is like on health effects that don't have a relationship, you shouldn't see an effect. Okay. So oil spills impact crop production and fish production. So this is through a destruction of ecosystems. And the argument is really running throughout this paper of oil spills impact mangroves and marine ecosystems. So it wasn't clear to me where the food insecurity is coming from. Is this just coming from crop loss or fish die off, right? And I don't know if you could separate either of these. That would be really interesting. Is like, okay, where's the food insecurity? Is it from marine ecosystems and like fish production, or is it coming from crop production? Okay, could there be other factors? So some confounding factors that are not being considered in this analysis. So one, I'm just like, kind of the one that I was thinking about throughout was just conflict, violence, and sabotage. So like conflict is highly correlated with oil spills. And then also conflict is highly correlated with agricultural production. So maybe there's a way that you can control for conflict. Could you provide evidence of oil burning after these spills, right? So I think there's like data on kind of fires, right? And maybe you could like time that with the oil spills. And then lastly, are oil spills like moving people out of agriculture? So maybe this is a reason as to why like local food insecurity, right? People are just leaving because of oil spills, or they're leaving because of conflict. Okay, and that's it. So thank you very much.
Thank you very much for the comments. Yes, the falsification test is being done, and that's the placebo. And there's no data in Nostra on how much oil is spilled. So that's a limitation. Then we consider data issues on LSMS disaggregation of health. The only thing we could get was the expenditure on health. So I'm not sure we can actually, except we get some other data set, but that's not within the purview of this study. But that's actually doable if you get some other data set for that. Then that's why we limited ourselves to exposure. If the households are exposed to crude oil spillage, what happens? That's just the basic idea. Yes, you can actually do some other further analysis and all that, but due to data limitations, we actually restrained ourselves to the fact that if an household is exposed to this issue, what happens? And that's it. Other comments are actually considered, and I could get them from you later. Thank you. I don't know if I have any other. Okay.
Yeah, I think I can speak loudly. Okay. I think this is really very interesting work. I like what you're doing a lot. One thing, related to your this cutoff zone and people being in different radiuses. One thing maybe that you could consider is using instead of like a binary treatment is having like the 1 over the distance from the oil spill. So then you can have some sort of measure how close you are to it to maybe get at some of this varying effect of people who were more exposed. But and also on this point, but more. I guess my main comment is that if the effect of the oil spill is reducing the agricultural productivity by damaging the soil, maybe what would be interesting to compare is people who are whether they're upstream of the oil spill versus downstream of it. So then people who are downstream would be more affected than those who are upstream. So I think that's quite interesting. And then also, and then looking also at the distance, you can see how the effects of oil spills sort of tail off as people get further away. But I really like this. It's very, very interesting one.
Thank you. Okay, so yes, that's possible to do that upstream, downstream, or do the quartile that he mentioned, such that you have some people between 1 to 30, 30 to 60, thereabout. We can actually group them and then incorporate that classification in the analysis. Yes, that's possible. Thank you.
Only one thing that I'm working also on oil spills and the treatment of acid hello that you see here there. So I also have, for instance, this is like continuous of my agricultural productivity, So I think that also just that moment I am controlling also for the distance to the households to the oil spills to households, but from the river side, the river course. So I'm doing this work. I also is interesting we can act we can talk about it because we know this data and there are some interesting results also concerning this issue.
Okay. Yeah. Thank you. I'll be happy to know more. Thank you. Yeah. Any other? Okay. Thank you for the session. Thank you for coming.